Good afternoon. We are team number 4 and we're going to explain rotation of axis in conic sections. The team members are Juan Manuel Lugo, Giacomo Ricaño Padilla, Daniel Orozco Fernández, Gilberto Rodríguez Prado, and the professor is Edgar Arturo Orozco Diaz.
So for the introduction, in this video, we're going to show the mathematical method of rotating conic sections, either a circle, parabola, ellipse, or hyperbola. And the rotation will be done in the Cartesian plane through the use of trigonometry. We're going to show the production of new x and y axis by rotating the original x and y. The new axis will be named x prime and y prime. And obviously, there's a new generation of new coordinates of x and y, coordinates x and y. And further along in the video, we're going to show the concept of the discriminant with its respective value for each conic section.
Okay, first, let's review a little bit of theory. We can, from the second degree formula, we can define which conic section we're talking about. For a parabola, the multiplication of the coefficient a plus the coefficient c is equal to 0. For an ellipse, the multiplication of a by c is greater than 0. And for hyperbola, the multiplication of a plus c is less than 0. The equation that relates the coordinates of a point in the original plane, in an original lowercase xy plane and a rotated uppercase xy plane based on an angle of rotations are the next ones. If we were to substitute the past equations in the general equation of the original xy plane, we obtain the next equation, which can be simplified with these expressions. And the method to eliminate the xy term, we have to equal the expression of b prime to 0. And then we obtain the following theorem that states that cotangent of the angle is equal to a minus c over b. For the discriminant for the second degree equation is b squared minus 4ac. For the conic sections that are rotated, they have the general form of a x squared plus b xy plus c y squared plus dx plus ey plus f equal to 0. The criteria are the following. For the rotated parabola, b squared minus 4a plus c is equal to 0. For the rotated ellipse, b squared minus 4ac is less than 0. And for the rotated hyperbola, b squared minus 4a is greater than 0.
So with the rules that my partner Giacomo gave us, we can solve the following problem that says so that we need to eliminate the x and y terms from the equations 153x squared plus 192xy plus 97y, it's equal to 225. Okay, by using the discriminant, b squared minus 4ac, and we substitute every single value, we got minus 22,500. So with the criteria that Giacomo gave us, we can know that the conic sections is an ellipse. So the first we need to do is to get the angle theta. Well, in this case is P. So cotangent of 2 phi is equal to 100 53 minus 97 over 192. We solve the fraction, and it's 7 over 24. We use the reciprocal to use tangent, inverse function on tangent. So we get 2 phi is approximately 73.7398 degrees, and over 2, we got the phi is equal to 36.8699. Now that we have the value of the angle phi, we can get cos of phi and sine of phi. Cos of phi is equal to 4 over 5, and sine of phi is equal to 3 over 5. And since x is equal to x times the cosine of phi minus y times the sine of phi, and y is equal to x times sine of phi plus y times the cosine of c, let's substitute every single value of x and y from the equation. So we end up with 153, and the values, the expressions that I already gave, but I won't say it's too large. And then we substitute cosine of phi and y, and no, cosine of phi and sine of phi in each single value. And then we solve the squares. We expand the expression. We use the distribution property, and we start to cancel some terms. For example, we end up that the xy terms is equal to 0, and then we divide everything over 225. So we end up with the x squared over 1 plus y squared over 9 is equal to 1. So these are the graphs. This is the graph. The rotated one is is the green one, and the normal one, or well, that the graph of the expression that we got is the blue one.
Some applications for this topic can be seen in X-rays, since doctors, in order to reconstruct the image from an X-ray, they take X-ray shots from different angles in order, as the X-ray is not a photograph, it's a graph with the density of the density of the tissue that is inside. So, well, when they rotate all these graphs, all the values of these graphs just end up allowing them through computer technology to just reconstruct the organs, especially the brain, since it's one of the most difficult ones.